Hello, this is Jan, developer of Simple Forest. So today in this tutorial I want to show you the last changes I made to the allometric correction of QSM models. What you see on the screen is a rather large tree, um, leaf off condition. The point cloud quality is decent. It was scanned in a forest observed by the Oxford University, thanks to Matthias Disney to providing me access to this cloud. So what I do is do the usual sphere following stuff, and I run the QSM median filter. You can already read about this in the PhD. And then there is a new step, QSM detect well-fit cylinders. So it takes as input the point cloud which you use to model the QSM and the QSM. So this is a QSM model, which is the output of the QSM median step filter, and the cloud which I use to model this tree. This is both the input, and if we look here, um, this step is designed to detect and visualize the good cylinders in your QSM model, um, and we can check, for example, the output and see this is the cylinders which my algorithm considered to be good. So it was extracted from those. We can see huge overestimation in the twig area, um, and only those cylinders will be used. So if we want, we can furthermore get information and uh, colorize by log fitting error. So if we see, I use this color palette. So green would mean good quality and blue is the worst quality. Um, so if you want to, and we can clearly see here is still overestimated cylinders which are blue. So if we want, we can fine tune and get again to the config parameters. So we can increase this. That means cylinders closer to the tip are rejected and ignored. So we want to ignore the tips better. And also we want to only take, instead of 50% of the remaining cylinders, 40%. So let's run it. I have to recompute everything now. So the recomputation did finish. It took around about 2 minutes in total. And if we go back here and visualize the cylinders, we can see the overestimated cylinders are less now. There is still a few remaining, but the majority should be good cylinders. So we can see these are quite well fit with the point cloud. Um, so why did we do this? So this next step, which you already know, takes another input in my newest releases, and the input is it needs to have this step pre-computed, the detect well-fit cylinders step. It's stored internally in the structure, and without this step the QSM allometric correction will not really work well. So the allometric correction the Simple Forest user guide, read my PhD, um, and um, so we can look at the parameters, and we leave this to standard. It will compute the allometric function only with those cylinders which you see here on the screen. So a lot of error cylinders are vanished. And then if we look at the final result, um, we have generated this tree model, and we have corrected all the twigs with the branch structure remaining intact. So that is a really nice result. Um, we can further export now. The exporter step, it didn't change the interface, but what we have now, so I run the exporter 2 times, one time on the allometric corrected result, this is here, this exporter, and on the uncorrected result, um, it produces now another output. You might know this folder structure. If you go to QSM, there's also statistics, and if we open this PDF, you can see for the vessel volume, for the gross volume, and for the gross length, you can see the allometric measures, and this is unmodified result. And if we open the second one, this is for the corrected QSM, how the function look like. So we have on the y-axis always the radius, and x-axis is gross volume as discussed in my PhD, or vessel volume or gross length as discussed in the Simple Forest user guide. The vessel volume is the best, cause in my opinion, cause it gives the clearest function in the uncorrected QSM. So we will fit here a power function, and there is also a second document for each tree generated with the tree name, and this is a bit about the stem quality. So we can see here the stem taper on both plots, and we can see here where the largest branches are. Of course, for the tree discussed, the largest branch is close above ground. This is this branch most likely, and then smaller branches come. And this one is how straight is the stem. So for each stem cylinder we compute the angle to the z-axis and build a histogram. So most of the stem is 15 degrees of the z-axis. So that might be here, that part. And this is, I think, it. Let me quickly show you one more flag in the QSM detect cylinders. So after the allometric correction, I run the detection 2 more times. The first time, with the same input results, I leave this button checked. It will show you only the good fitted cylinders, and the all of those cylinders have never been modified. This is true measurements, not statistical corrected ones. And if you look here on the second step, I unchecked this box and now all cylinders are displayed. So, and again you could visualize uh, with the fit quality. So the twigs are not fitted that good. In majority the branches are fitted quite well. The root is not fitted that good, and we always have errors in the at the branch junctions. There the fit quality is worse than between two branch junctions. And I hope you find it helpful. Please play around with these new steps or old steps in a new manner. And this is it. Have a nice day and goodbye. Hello, just for completeness, I show you where you find the script and the data. This is my GitLab repository, um, including a binary folder, um, which I need to update. I need to update the Windows executable. There is a folder test scripts and data, and then you can go to Rhythm and you find the script which I used the cloud in the zipped output format, and also my simple forest output data. Um, so this cloud, the fieldwork was funded by the Meteorology for Earth Observation and Climate project um, within European Meteorological Research Program. The EMRP is jointly funded by the EMRP participating countries with Euramet and the European Union. So this is it. Have fun. Bye bye.